Hey, so in this lecture we will cover some commonly used terms in Unreal Engine. I will start on this page, the foundational knowledge page. You can see we have some useful pages on the Unreal Editor interface, Unreal Engine terminology and so forth, tools and editors. So this is a good place to start. I will jump over to the Unreal Engine terminology page. Note that I will reiterate some of these terms as we go along throughout the rest of the course, but this is a good place to start and a good page to bookmark as a reference. Mainly because while I may summarize some things to you, I may not summarize everything in one place as it is here in the documentation. It's a good idea to start getting used to the documentation, searching the documentation and so on. So again, some commonly used terms when working with Unreal Engine. Scroll down, note to the right that you have a link. So for example, if I want to go to the actor section, I can click on actor and that will take me to the actor section. Click on project, that will take me to the project section and so forth. Go ahead and give this page a read, but don't worry about remembering everything, because as I mentioned, I will be reiterating many of the concepts as we go along throughout the course. To get started off with, we have project at the top here that holds the content for your game. It contains a number of folders such as blueprints and materials, so this brings everything together. The content browser is going to show the same directory structure found inside the project folder. Every project has a .uproject file associated with it, and you use that to open or save your project. Of course, we can create our own projects from scratch, or we can use existing templates that are provided by Epic Games. We can even set up our own templates if we want. We can also download complete projects from the marketplace. Speaking of, once we have a project created, we can add asset packs to an existing project. We can also purchase those asset packs on the marketplace. Then we have the blueprints. The Blueprint Visual Scripting in Unreal Engine is a gameplay scripting system. With that, we use a node-based interface to create gameplay elements from within Unreal Editor. In a text-based programming language such as C++, you will go and write text out line by line. But with the Blueprint Visual Scripting system in Unreal Engine, we use a visual scripting system, and we use these nodes that we hook up together to create gameplay elements. Whether we use the Blueprint Visual Scripting system or C++ to code gameplay elements, both of those are object-oriented programming languages, and an object is basically a building block that contains essential functionality for your assets. With those, you can create parent-child relationships, where one object inherits some functionality from an object, a parent object. And then we have a class. A class is going to define the behavior and properties of an actor or an object in Unreal Engine, and an instance of a class is an object. As I mentioned, we have parent-child relationships. We can create subclasses from a parent class. And as I mentioned, classes can be created in C++ or in Blueprints. An actor is any object that can be placed into a level, such as a camera, a mesh, or a player start location. An actor in Unreal Engine has the property that it supports 3D transformations, translation, rotation, and scale. And because of that, they can be created, or in other words, spawned, and also destroyed through gameplay code, again C++ or Blueprints. You might be thinking, what is a mesh? In this example, I'm in the first person template, and I'll go ahead and select this mesh that the level contains, which is a weapon pickup. I'll press F to frame up on that, so this is the weapon pickup. With that selected, I will select the skeletal mesh component, and then we have the mesh section down here. And then I can double click on this here to open up the skeletal mesh, for example. And then we have this preview. Typically looks something like this, but I will switch to wireframe. I would like to note that you can also switch to wireframe here by clicking this drop down, switch to wireframe. Don't worry about all of these settings, we'll go over that again in a future lecture, but this is the wireframe. This is the mesh or the construction that makes up that particular object or actor. So again, you can double click on the mesh here, and that will now take us to the skeletal mesh editor. Okay, and to find help on that, you can click on help, and you can go here to skeletal mesh editor documentation. Alright, so what I'll do is, under the preview scene settings, I will go and turn off the show environment and the show floor, and I'll just navigate around a bit using the right mouse button. With that selected, you can press F to frame up on it, hold the right mouse button down, and WASD to move around a bit. But this is basically the mesh that makes up this particular object. Actually, what I can also do is I can click on this option right here, and then that vertical sort of ellipse like button almost, clicking play here. And so this is basically the construction that we get the construction that makes up the 3D object. And this is done in a 3D program such as Blender or Modo. You can also do 3D sculpting using digital sculpting applications such as ZBrush. And if you are not familiar with those, I'll just go and stop this. If you are not familiar with those, then I would suggest that you go and do some research on that. In this course, we are not really concerned with 3D modeling, which is the process of constructing 3D objects such as this. You can see you have all of these triangles that makes up this object. I'll just switch back here to lit. And the reason why we have materials on that is because we actually have a material applied. So again, with that skeletal mesh selected in the material section, I'll just go and double click on that to open that up. And you can see you have masks and so on that makes up this particular material, which is then applied to the actor. But I just wanted to show you what a mesh is. Again, here we can also go to the wireframe viewing mode, and then we can see the mesh that makes up the objects in our scene. All of these objects are meshes, alright? The important thing to remember here is that an actor is any object that can be placed into a level. You don't have to worry about casting, we will get back to that at some point in the future. A component is also an important element in Unreal Engine. It is essentially a piece of functionality that can be added to an actor. If you have a background developing in the Unity engine, you'll be familiar with components, because you basically use components for almost everything in Unity. And a component is really useful in that we write reusable components. Again, those are pieces of functionality that we then add to an actor. We want to reuse as much as we can, instead of having to re-implement the same stuff over and over again. So the actor can then use the functionality that that component provides. For example, you can add a spotlight component to your actor, and then that actor can emit light like a spotlight. And then we also have an interesting one, a useful one here, which is the rotating movement component, which will make your actor spin around and so forth. Okay. I mentioned previously that we use object-oriented programming in Unreal Engine, and that we have inheritance hierarchies, where for example a child class can inherit functionality from a parent class, while a pawn is a subclass of an actor, and a pawn can serve as an in-game avatar or persona, such as a character in a game, or a paddle that you want to move around on the screen using keyboard input. Maybe you're building some Brick Breaker game or Pong or something like that. So again, pawns can be controlled by the player, or actually by the game's AI as non-player characters. Another term here is possessed. When a pawn is controlled by a human or AI player, it is considered possessed. If it is not controlled, then it is unpossessed. For example, as you go through and debug your game, you can possess your player character or your pawn, and you can then unpossess that to inspect your world, for example. And we'll discuss some of this again as we go along in future lectures. And then you have a character which is a subclass of the pawn actor. You can see as we go down in the inheritance hierarchy, we add more features and functionality. So the pawn is an actor, but it has additional functionality in that pawns can be controlled by a player, whereas the character is a subclass of the pawn actor. And once again, we add additional functionality. The character subclass includes collision setup and input bindings for bipedal movement. So again, this builds on the pawn actor class. You have a player controller, which is going to take player input and translate that into interactions in the game. We will talk more about the player controller as we go along as well. Same with the AI controller. You're not concerned with the AI controller at this point. Also not the player state. And basically the game mode is going to set the rules of the game that is being played. Again, we will talk about this in a future lecture. You don't have to worry about this too much at this point. Same with game state. You have volumes. Volumes are bounded 3D spaces that have different uses. For example, you have trigger volumes. Trigger volumes are programmed to cause events when an actor enters or exits them. Then you have some of the basic stuff. Now this is also interesting here. A level is a gameplay area that you define. A level is saved as a .umap file. So notice sometimes level and map is used interchangeably here. These are referred to as maps or levels. A level basically contains things, meshes and actors and objects that a player can see and interact with. Then beyond that we have a world, which is basically a container for various levels that make up your game. A world handles the streaming of levels, basically the loading and unloading of levels. This is useful if you want to create large worlds, because for efficiency you can stream in, that is load or unload certain parts of a larger world by streaming certain levels in and out. But again, more on this maybe in a future lecture. I just mentioned this here out of interest, so there are things that you don't have to worry about too much at this point. but this is a great reference in the case where you forget some of the terminology. We can also differentiate between the Unreal Engine and the Unreal Editor. The Unreal Engine basically powers our project or game frame by frame. It is essentially the low-level technology or code that allows for physically accurate rendering, that is physically accurate materials, light reflections and so forth, physics and physics interactions, animations and so on. So it's like the engine in your car, it is what powers your game, and you can differentiate between that and the Unreal Editor, which is a collection of editors containing visual tools used to create gameplay elements. You will use these tools to puzzle together your games. In the level editor, you will block out your level, you will add meshes in there, define where the player starts playing the game. You may also define where AI spawns to start off with when you load that level. You have different editors. You have the level editor, the blueprints editor. Instead of using some third-party tool to write code such as you would with Visual Studio, for example, to write C++, the blueprints editor allows us to code using the node-based visual scripting system in Unreal Engine within an editor that again is built into the Unreal Editor. You have the materials editor, you have static mesh editor, and so forth. I just wanted to mention this because sometimes people do differentiate between these a bit. They refer to the Unreal Editor and then you are confused on what that actually means. But it doesn't really matter all that much, you can refer to it as the Unreal Engine. That is going to wrap up this video on basic Unreal Engine terminology.